All right, we're looking at the 5-3 video, and our goal here for 5-3 is to multiply matrices of appropriate dimensions. So, much like with addition and subtraction, there's some size requirements when it comes to multiplying two matrices. One thing I really want to emphasize, this is not as basic as addition and subtraction. Okay? I have to emphasize that. Is you have to flip a little bit of a switch whenever you multiply matrices. All right, so the hint here is that two matrices, when we multiply them, they have to have the appropriate dimensions. So we're going to make this note. So first things first, note two matrices have requirements that must be met before they can be multiplied. And so here's what I'm going to do. I'm going to write it out in row by column form first, and then we're going to take a look at what happens. And I'm going to give some steps, and then we're going to do a few examples. So, the first things first is we need to determine the size of the matrices. So we want to look at the dimensions of both matrices. So the first matrix is going to have some row by column. So I'm going to call that R1 by column 1. So row 1 by column 1. So the row of the first, column of the first. So this is the first matrix. We're going to multiply that with a second matrix, right? Row 2, column 2. So this is the second matrix. So the size of the first and the size of the second. Now, in order for this to work, ooh, look, I used green. That's neat. These numbers must match, okay? If the column of the first does not match the row of the second, then you cannot multiply them, okay? So I'm going to write it like this. I'm going to say that C1 must match R2 exactly. Otherwise, we cannot multiply. All right, so C1 and R2 have to match exactly, otherwise we can't multiply. Here's the other cool thing about this, is that the resulting matrix is going to be R1 by C2. So, the second step, the resulting matrix, the second notes that I want you to take here, the resulting matrix will have the dimensions of row 1 by column 2. Okay? So this is going to be the resulting matrix. So if the inside numbers match, cover them up, then the resulting matrix is going to be this size. So R1 by C2. All right. So let's go through. I'm going to go ahead and I'm going to write down the steps here. So the steps in order to multiply these out. So step 1, we would need to determine if it's possible. Determine if possible. In other words, C1 has to match C2, right? Step 2 is we want to set up the resulting matrix So that means R1 by C2, and we're going to use a blank array, and I'll show you what that looks like when we get to that step. Step 3 in this process, we're going to use the resulting matrix as a reference so that step 4, we can find the sum of the products of the row from the first and column of the second. All right, so this is going to be, watch the example. It's easier done than said. It's hard to write down the process. It's hard to use the words to say the process. Much easier just to do an example. So, here we go. Those are the 4 steps that it's going to take in order to multiply 2 matrices. So I'm going to try and leave those right up at the top here, if I possibly can. I can. All right. So our first example, let's do this. We have this. We have 1, 5, -7, 2, 4, 0. And we're going to multiply that with a 4, 1, -3, 0, -1, 5. All right. So, step 1 says determine if possible. So, is it even possible that I can multiply these 2 matrices? So the first thing we're going to do is say, all right, what's the size of the first matrix? Well, the first matrix is a 2 by 3. So we have a 2 by 3. And the second matrix has 1, 2, 3 rows and 2 columns. And so this is a 3 by 2. All right. So the first question is, do these 2 numbers match? And the answer here is a resounding yes. These numbers here match. So that means that the size of the resulting matrix is going to be a 2 by 2. So the resulting matrix is a 2 by 2 matrix. So here I go. For step 2, set up the resulting matrix. So here's our resulting matrix. It will be a 2 by 2. Look how much space I'm giving myself here. All right, it is a 2 rows, 2 columns. All right. Now I'm going to use this resulting matrix to find or to reference what I'm going to be multiplying. So this position, this is row 1, column 1. So I'm going to multiply, all right, I'm going to find the sum of the products, row of the first, column of the second. So I'm looking at the first row here, because this is row 1, I'm going to use row 1. Since this is column 1, I'm going to use column 1 from the second matrix. So row of the first, column of the second. Since I'm in row 1, column 1 for this spot, I got to use row 1 here, column 1 here. And then I'm going to multiply the corresponding entries. So not necessarily corresponding. It's difficult to say the corresponding. But I'm going to multiply first by first, second by second, third by third. So 1 times 4. And then sum is plus 5 times -3 plus -7 times -1. I did not give myself enough space. That looks terrible. I am really sorry. So let's do this. Let's set up this matrix down here. We don't need the directions anymore. All right. So let's try that one more time. Now we have a little bit more space. So corresponding, or first by first, second by second, third and third, and we're going to add them up. So we have 1 times 4 plus 5 times -3 plus -7 times -1. All right, so now I'm going to look at this position. This is row 1, column 2. So row 1, and now I'm going to look at column 2. 1 times 1, so 1 times 1, plus 5 times 0, 5 times 0, plus -7, -7 times 5, right? First by first, second, second, third, and third. Now, I'm going to go down to this position. I'm in the second second row, first column. So I need the second row from the first, and I'm going to use the first column from the second matrix. So entry by entry, 2 times 4, so I get a 2 times 4 plus 4 times -3, 4 times -3 plus 0 times -1, 0 times -1. And now for this position, we're in the second row, second column. So I want to use the second row and the second column. We're going to go entry by entry. So first entry, second entry, third entry. So 2 times 1, so we have a 2 times 1 plus 4 times 0 plus 0 times 5. All right, now I can just clean this up. 1 times 4, we got 4. 5 times -3 is -15. -7 times a -1 is a +7. I'm just making notes to myself here. 1 times 1 is 1. 5 times 0 is 0. And -7 times 5 is -35. We can add those up here in a minute. 2 times 4 is 8. 4 times -3 is -12. 0, that's 0. 2 times 1 is 2. 4 times 0 is 0. 0 times 5 is 0. All right, so now that means that my final answer, multiplying these two matrices, my final answer is going to be a 2 by 2 matrix. So 4 minus 15 is -11. -11 plus 7 is 4. Is that right? There's no way that happened. Oh, it's a -4, excuse me. That makes so much more sense. All right, 1 plus 0 is still 1. 1 minus 35 is a -34. 8 minus 12 is a -4. 2 plus 0 is just 2. And so this is the resulting matrix. So this would be my answer. There's going to be other examples on the website. So double check and make sure you watch all of the other examples. That way you kind of get the idea of this. Ask as many questions as you possibly can and make sure you make detailed notes.